Hello everyone, welcome back to my channel. So today we are going to solve the previous year gate questions from signal flow graph by and also finding the transfer function by using Mason's Gann formula. So the first question is the overall transfer function of the system in figure is this, and here are the four options given. So let's see the solution, as this is the block diagram of a system. So here W is the input, Y is the output, and let's find the number of forward paths. As P1 is, this is the first forward path and its gain product is Z, and the second forward path is W to G, G to Y. This is the second forward path and its gain product is G, and P3 is G, G to H, H to G, again Y. So this is the third forward path and its gain product is G square H and G, again H, again G. So this is the fourth forward path and its gain product is G square H. Let's see the number of loops. G H, G H, G H, G H. So one loop is there and its gain product is G square H square. So by using Mason's Gann formula, summation I is equal to 1 to n pi delta I by delta. Here 4 forward path is there, so P1 delta 1 plus P2 delta 2 plus P3 delta 3 plus P4 delta 4 by delta. Here only one loop is there and this loop is touching to every forward path. So delta 1 is equal to delta 2 is equal to delta 3 is equal to delta 4 is equal to 1 minus 0 is equal to 1. P1 is G plus P2 is G plus P3 is G square H plus P4 is G square H by delta 1 minus sum of the individual loops, that single loop is there, G square H square. Let's simplify 2G plus 2 G square H by 1 minus G square H square. From here take 2G common, we get 1 plus GH by 1 minus G square H square. And by the formula, A square minus B square is equal to A plus B into A minus B. 2G 1 plus GH by 1 minus GH 1 plus GH. This 2 will get cancelled. So the answer is 2G by 1 minus GH. So option B is the correct answer. And the next question is, and the second question is, signal flow graph is used to obtain the options are there: stability of a system, transfer function of a system, controllability of a system, or observability of a system. So as we know, signal flow graph is always used to obtain the transfer function of a system. So B is the correct answer. And the third question is, the signal flow graph of a system is shown below, and U of S is the input and C of S is the output. So this is the signal flow graph, and assuming H1 is equal to B1 and S0 is equal to B0 minus B1 A1, the input output transfer function G of S is equal to C of S by U of S of the system is given by. So we have to see the solution, and these are the four options given. So let's see the solution. So as here signal flow graph is given, so from here we will find the number of forward paths. Let's see how many forward paths are there. H0 1, 1 by S1, 1 by S1. So P1 is equal to H0 by s square. This is the GAN product. Let's see the second forward path. Is this? No. Again from here h1 1 by s1, so p2 is equal to h1 by s. Now see the number of loops. This is the first loop, so L1 is equal to minus A1 by S, and second loop 1S1 1 by S minus A0, so its GAN product is minus A0 by S square. By using Mason's GAN formula, transfer function is equal to, here two forward path is there, so P1 delta 1 plus P2 delta 2 by delta. Let's see the delta. One value 1 minus 0. Why 0? As to this path all the loops are touching, no non-touching loop is there, so 1 minus 0. And for delta 2, this is the second forward path and this is the non-touching loops, so 1 minus, its GAN product is minus A1 by S. So by putting the value, we get h0 by s square into 1 plus h1 by s into 1 plus a1 by s by 1 plus a1 by s plus a0 by s square is equal to h0 by s square plus h1 by s plus h1 a1 by s square by 1 plus a1 by s a0 by s square. Now by taking the LCM, we get h0 plus h1s plus h1a1 by s square by s square plus a1s plus a0 by s square. And now we'll put the value h1 is equal to b1 and h0 is equal to b0 minus b1 a1. By putting the value b1 a1, these two will get cancelled and we will get b0 plus b1s by s square plus a1s plus a0. So this is the answer, and from here C is the correct option. And the next question is, for the signal flow graph shown in the figure, which one of the following expression is equal to the transfer function y of s by x2 of s, where x1 of s is equal to 0. And this is the signal flow graph, and here are the four options given. So let's see the solution. So number of forward paths from x2 to y is 1 and its GAN product is P1 is equal to G2. And let's see the number of loops. So 1 G1 minus 1, G1 G2 minus 1, two loops are there, so L1 is equal to minus G1 and L2 is equal to minus G1 G2. So let's see the transfer function y by x2 is equal to P1 delta 1 by delta. We get 2 into 1 by 1 minus G1 minus G1 G2. We get G2 is equal to 1 plus G1 plus G1 G2. So this is the answer, and from here the option B is the correct answer. Let's see the next question. The signal flow graph of a figure shown below has dash number of forward paths and dash number of feedback loops. So here we have to find the number of forward paths and number of loops. So let's see the forward path A, H, F, G. One forward path A, H, F, G. Next see the second one A, B, D, F, G. A, B, D, F, G. Second forward path. Third A, K, M, G. And the fourth one is A, H, that over A, K, L, F, G. A, K, L, F, G. So number of forward path is 4. Let's see the loops. DE is one loop. L1 is equal to D, L2 is equal to C, L3 is equal to MN, and L4 is equal to LFN. Here any loop is there? No, here no loop is there, only 4 loops are there. So the number of forward paths is 4 and number of feedback loop is 4. So this is the answer.